Hey YouTube, thanks for visiting. Hope all you are doing well. So in this video or in this lecture, we are going to solve the West Bengal set 2025 questions paper, and this is the part 2 of our solution series of West Bengal set 2025. The exam date was 18th of December 2025, and in the part 1 we covered the complex analysis. We have covered the complex analysis. Number 2 is linear algebra, and number 3 is one questions from Boolean algebra. So those who have not watched this video or lecture, please watch this lecture till watch the lecture and then come to, or you can watch this first lecture also. And in the part 2 of today's lecture, we will cover the ODE, PDE, integral equation, and calculus of variation. So this is based on completely of applied maths, and in the first lecture we have covered the you can say the pure maths. Okay, so let's start, and before starting I am requesting you to all those who are new in my channel, please give a like to this video, share with your friends, and subscribe the channel. Fine. So this is the question, and all the questions are from X series of the West Bengal set paper. So the question number 19, it says that uh, the differential equation dy dx equal to y to the power 1/3 and y0 equal to 0. This is the initial value problem, has unique solution, no non-trivial solution, finite number of solution, infinite number of solution. So this is very classical questions, or classic questions you can say, of CSIR net and GATE. So the theory behind the question, which is very easy, that if we get y dy dx is equal to y to the power suppose alpha, where alpha belongs to 0 and 1, and the initial condition is y suppose b, this is equal to 0. This is a very standard question. B belongs to real number. Then what happened? It has infinite solution. Then it has infinite solution, and one case 2 is if y dash equal to minus y to the power alpha and all the conditions are same, then it has the unique solution. Unique solution. So here it has given that dy dx equal to y to the power 1/3, that is 1/3, this 1/3, 1/3 belongs to 1/3, or yeah, 1/3 belongs to 0 1. So that means, and y0 equal to 0, that is b belongs to r, then it has obviously the infinite number of solution. Fine. Next question. Next question says that the particular integral of the differential equation, it is given that the differential equation is given that d minus 3 dq minus d into y, this is equal to e to the power x minus exponential minus of x. Fine. This is also very easy. So we know that the particular integral pi is equal to 1 by dq minus d into operating on e to the power x minus e to the power minus x. Now note that if these types of questions come, then we first put the coefficient of e to the power x, the coefficient of x here, and the coefficient of x, e to the power x is 1 and minus 1, and if we put here 1 and minus 1, then we get 0 in both the cases. So here we have to do is we replace d by d plus 1 for d to the power x, and d by d minus 1 for d to the power minus x. Fine. Okay. So let's do it. Fine. So 1 by d plus 1 whole cube minus d of e to the power x minus 1 by d minus 1 whole cube minus sorry, this was d plus 1 and this is d minus 1 of e to the power minus x. So this is equal to e to the power x by operated only, so dq minus 3d square plus 3d, so plus 3d square plus 3d plus 1 minus d minus 1 plus d minus d got plus 1 minus 1 got cancelled, minus 1 by 1 not 1 e to the power minus x by dq minus 3d square plus 3d minus 1 minus d plus 1. These both are cancelled out. So this is equal to e to the power x by dq plus 3d square plus 2d minus of e to the power minus x by, okay, e to the power minus x by what? dq minus 3d square and plus 2d. Fine. I think we get these two. Okay. So now if we take one common, sorry, d common, so e to the power x by, if we take 2d common, then we get 1 plus d square plus 3d by 2, right? And minus e to the power minus x by, if we take 2d common, then we get 1 plus d square minus 3d by 2. Okay. Now we know simple inverse. So this will get e to the power x by 2d into this inverse. Inverse means what happened? 1 minus d square plus 3d by 2 plus dot 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 and operated on 1, and this will get actually 0. So we get actually e to the power x by 2d. So from here we get e to the power x by 2 into d means integration of only dx and minus e to the power x by similar 2d into we get 1 minus this will be, sorry, 1 plus and 1 minus 1, no, both are plus, okay, right. D square minus 3d by 2 plus dot dot operated on 1. So this is again we get minus e to the power x by 2 into 1 d means integration dx. So we get e to the power x by 2 into x minus e to the power minus x, this is minus x by 2 into x. That means the final answer is equal to what? The final answer is e to the x by 2 into e to the power x minus e to the power minus x. So this is the answer of our given problem, which is option D. Okay. Next question. This is also very nice question. Many times I think I do already practice of these questions. So before solving the question, I will share some techniques to solve this type of questions. There are actually three techniques. Number one is, now first we say let if here x with respect to x is problem is given, we write x double dash plus lambda into x, this is equal to 0. Okay. Now number one is based on the boundary condition, if 0 less x less L or sometimes A less x less B. Fine. So we write the formula using on this. So 0 less x less L. Then number one is, if the condition is like given x0 equal to 0 equal to x of suppose L, then the eigenvalues are, then eigenvalue this lambda is equal to what? N square pi square by L square, and in all the cases the eigenvector or eigenfunction given by y equal to a sine root lambda x, where root lambda is given by this. Fine. Number 2 is if the boundary condition is given like x 0 equal to 0 and x dash l equal to 0, then the solution or the lambda will be like this: lambda equal to 2n plus 1 by 2 into pi by l whole square. Fine. And number 3 cases is, so remember these three things, then you can doing these types of, or you can definitely do these types of questions in fractions of seconds. So if ya equal to yb format is given, suppose ya equal to y not y x, x a equal to x of b and x dash a equal to x dash b, then the lambda is given by 2n pi by l whole square. And all the cases the eigenfunction is given by a sine root lambda x, where lambda is defined by this. But in this question, the question given here is not a standard type of problem. So how can we say solve this question? So first is given that the ODE is x double dash plus lambda x, this is equal to 0. And if this is the ODE, then we can definitely write very easily the solution: x equal to a cos root lambda t plus b sine root lambda t. So these are the standard protocols that you can remember, and if these types of you forget in the exam or the format is not in the given form, then this is the standard procedure to solve these types of question. Now given that x not 0 equal to 0, that means definitely we get from this equation a equal to 0. Okay. So a equal to 0 means now x equal to here b sine root lambda t. Now the second condition is based on what? X dash. So x dash, that is dx dt is equal to root lambda b cos root lambda t. Now the second condition is x pi is equal to x dash pi. Now x pi means this one. So b sine root lambda pi, this is equal to x dash at pi means root lambda b cos root lambda pi. And since b not equal to 0, if b equal to 0, then we get trivial solution, but we are interested in non-trivial solution. Therefore we can cancel out b from both sides. This is a very basics class 9-10 concept. So sine I think, oh sorry, this is plus, this is equal to 0. So sine root lambda pi plus root lambda cos root lambda pi is equal to 0. Now if we divide this by cos root lambda pi, then we get tan root lambda pi plus root lambda, this is equal to 0. And this is the answer. Which one? Option C. So option C is the right answer. Next question. This question is on the Wronskian. So first, given that let y1, y2 be two linearly independent solutions of differential equation uh, x double dash, given that x d2y x y double dash minus 2x square y dash plus e to the power x equal y, this is equal to 0, and satisfying y0 equal y1 0 y2 0 y dash 0, this, and all defined as 0. That means you have given here Wronskian at 0. This is equal to y1 0 y2 0 y1 dash 0 and y2 dash 0, and the values are 1 minus 1 1 1, and the determinant is here clearly 1 plus 1 2. Now if this is given, then we know that by Abel's formula, what is given Abel's formula? Else formula says that if Wronskian is this, then general Wronskian is given by a constant. Here we take the constant at W naught, because in that's why this constant is given, e to the power minus integration P dx. Now what is this P? P comes from this equation. Now in this case, this P is given taken by the uh, standard differential equation, y double dash plus py dash plus qy is equal to r. Now if we compare these two equation, or we can write this equation in this form, then divide x both side, we get y double dash minus 2x y dash plus e to the power x by x into y equal to 0. Now what is the value of p here? P is equal to minus of 2x. So now put here minus of 2x first. So where Wronskian at x, this is equal to Wronskian of 0 means 2 into e to the power minus of minus 2x dx, that is e to the power 2 e to the power 2x into x square by 2 into x square by 2, that is 2 e to the power x square. Now we have to find Wronskian at x equal to 2. So Wronskian at x equal to 2, this is equal to 2 into e to the power 2 square, that is 2 e to the power 4. The answer is option C. Next question. This question says that uh, the partial differential equation del x del z del x plus 2x y cube del z del y is equal to z cube. General solution can be expressed in the form f equal to f ub equal to 0, where ub are given by. So this is a very basic problem based on Lagrange's formula or Lagrange's solution. We write the Lagrange's first. We write the Lagrange's auxiliary equation. Lagrange's auxiliary equations are, so dx by coefficient of del z del x, dy by coefficient of del z del y, and dz by z cube, dz by r here. Fine. P del z del x plus q del z del y equal to r. So if we take these two first, then we get x dx, this is equal to, or we can write 2x dx, this is equal to dy y to the power minus 3. So x square by 2, this gives x square, 2 by 2 cancel, is equal to minus 3 plus 1, minus 1 by 2 y to the power or by y square, minus 1 by 2 y square plus suppose c1. So this implies x square, and this will be 1 minus plus 1 by 2 y square is equal to c1. So now you can check that means this c1 is either u or b. So here we see that the form of u given like that. So here u, this u not match, cancel, this option cancel, this u also not match, cancel, this u also not match, cancel. So option D is the only answer of these questions. Or you can also check the v function. So if we take also this first and third function, then dx is equal to dz by z cube, and this gives x, if we integrate here we get x minus 1 by 2 z square, this is equal to c2, and the solution is written by x c1 c2 is equal to 0, which is equal to c1 or uv, you can write uv functions. So that means u equal to this and v equal to this. So option D is the correct answer of this question. Now next question, this is also again from PD. Question says that the general solution of del j del 2z del x to minus 3 del z del x plus this equal to e to the power 2x minus y is of the form. So it is given, if we write that del x or this is equivalent to d, and del y is d dash, then you have given the differential equation or OPD like d square minus 3d dash plus 2d dash square, this is equal to e to the power 2x minus y. Now first we find the auxiliary equation by putting d is equal to m and d dash equal to 1, or either you can choose d equal to 1 and d dash equal to m. This is standard procedure, and which is this one. So we get the auxiliary equation like m square minus 3m plus 2, this is equal to 0, and here we get the value of m is equal to 2 and 1. And if the value is 2 and 1, then auxiliary function or complementary function, we can write CF, complementary function is equal to what? Some function f of x plus y, x plus my, or y plus mx. So y plus mx means y plus 1 into x plus g of y plus 2x, m1x and m2x. And if we, the standard form is, if m1 m2 are the distinct roots of this auxiliary equation, then the differential or the complementary function, right, like that way, y plus m1x plus f2 of y plus m2x plus so on. So this is the CF. So now we can discard the option based on CF. This is minus, so cancel out. This also minus, plus, cancel out. But we get both the roots are plus. Here in these two option we get same. Then we have to find the Pi now. Fine. So Pi equal to what? Pi equal to 1 by d square minus 3d dash plus 2d dash square on e to the power 2x minus y. We first put the coefficient of this and this. So d dash equal to d equal to coefficient of x, that is 2, and d dash equal to 1. If we get this value is non-zero, then that will be the Pi. Otherwise we have to replace d by d plus 2, d dash by d dash plus 1. So e to the power 2x plus y, get d square means 2 square minus 3 into 2 into minus 1 plus 2 into minus 1 square. So this is equal to e to the power 2x plus y by 4 plus 6 plus 2. This is e to the power 2x plus y by 12, which is non-zero. Since the is non-zero, therefore this will get the plus function. Therefore this is minus given. So this will not the answer. Answer is option A. Fine. Now next question. This question is from integral equation, and the question given says that the initial value problem d2y dx2 plus y equal to 0, x greater than 0, y 0 equal to 1 and y dash 0 equal to 0, equivalent to the Volterra integral equation. So there are two ways that can we solve this question, in which, so first one is you have to integrate this one to get the correct answer, or you can do by checking the options. If we just differentiate this option to get this one by one to check the given differential equation. So if we choose option A first, which is ux is equal to 1 plus integration 0 to x, this will not ux, the question should be in yx. Okay, t minus x into, because here y is given na, all y are given, so that should be in yt, or otherwise you can choose this one, no problem. So this, now if differentiation, so here we need to apply the Leibniz rule for differentiation. What is the rule? If f x t, this is equal to integration, suppose gx to hx, f of xt dt, what is the rule says? It says that f dash equal to integration gx to hx del x of f xt dt plus what f of x gx into del gx del x minus f of x hx, sorry, this will first is upper limit then minus lower limit, hx minus gx x gx into del x of gx. Fine, this is the formula. Now apply this, so we get y dash x and no, y dash x equal to 0 plus integration 0 to x del x of this means minus 1, so minus 1 into yt dt plus del x of this, and if we put here the x, then x minus x, it will be 0 0, and this is 0, so if we differentiate this limit then we also get 0. Fine. Next, again differentiating, dy double dash is equal to integration 0 to x del x of this functions is 0 because there is no functions of x plus sorry minus, this is minus given na, minus plus minus 1 into y at x and ddx of x minus 0, this is equal to 0 minus yx, so that means y double dash plus yx is equal to 0. So this we get satisfied the given question. Therefore, this is option A is the correct answer. You can check also other options. And y0, the value of y0. So here we can find that this y0 equal to 1 and y dash 0 equal to 0. So just you can put it in the equation and you can check. Also first you can guess this answer by putting this. Fine. Putting the initial condition. So this is one procedure, and another one procedure we can do also, that integrating these portions and getting the answer. Next question is this one. For the linear integral equation, this, what is the resolvent kernel? Okay. So what is the resolvent kernel? So the question given that ux is equal to lambda plus integration 0 to half us ds. Fine. So first it is given that we know that this will be like integration kxt u kxs us ds, this integration portion only, and therefore it is given 1, that is first k which is given is kxt equal to 1, which we say as k1xt, sorry xs, here it is given s. Now k2 xs, this is equal to integration 0 to half, we know that k1 xz, k1 xz into dz. K1 value is 1, this is constant value, so 0 to half 1 dz, this is 1 by 2. Similarly, if we calculate that k3xz, k3xs, this is equal to integration 0 to half k2xz into k2xz into kxs zs dz, which is this value is half and this value is first value which is 1. So integration 0 to half into 1 dz, that means this value is 1 by 4, which is 1 by 2 square we can write. Fine. Similarly, we get calculate k4 xs, this is equal to integration 0 to half k3xz into kzd zs dz, and integration 0 to half k3xz means 1 by 4 into 1 dz, integration we get 1 by 8. This is equal to 1 by 2q. Now you know that the resultant kernel formula are x, z and lambda. This is equal to summation of this k1, k2, kn. Fine. So this is k1 is equal to what? 1, then 1 by 2, then 1 by 2 square, then 1 by 2 cube plus so on. So we know that this is an GP series. The sum of this GP series is 1 by 1 minus half. It is equal to 1 by half, which is 2. Therefore, the answer is 2. Next question. This question is from calculus of variation. Two questions of from comes from integral equation and two questions from calculus of variation. So, we know this given that the extremal is of the form what? So, this. So, f is equal to given y dash s square by x cube. We know that the Euler-Lagrange equation given by what? dx of del f del y dash minus del f del y is equal to 0. And no terms of y is given, therefore this term vanishes. That means dx of del f del y dash means what? Del f del y dash means 2y dash by x cube is equal to 0. And this differentiation is 0 means 2y dash by x cube is equal to constant. So this means we can write y dash equal to some constant into x cube. This is equal, this means if we integrate, then we get some constant y equal to some constant into x to the power 4 by 4 plus another constant, constant 2. So this is equal to, we can write, and this is complete constant. So c1 x to the power 4 plus c2, the form which where c1 c2 are constant. So option B is correct. This is the last question of today's lecture, calculus of variation, from calculus of variation. Consider the functional I equal to this, where this and this, where y belongs to C2, f has the second order continuous partial derivative with respect to y and y dash. y1, 1, y2 are given real numbers. Let y equal to yx be an extremizing function of the functional I. Then along the extremizing curve, which is the answer? So given that f is equal to f of y dash, this is independent of x. And if this independent of x, then direct we write the Cauchy or Euler-Lagrange equation. Euler-Lagrange equation is given by f minus y dash del f del y dash is equal to constant. Option D is the correct. Now, if you forgot this, that independence of for independent of x, for independent of y, how can this comes? Okay, just 1 minute needed, 1 or 2 minutes we can explain. So the standard equation, standard Euler-Lagrange equation is what? Euler-Lagrange equation is d dx of del f del y dash minus del f del y, del f del y is equal to 0. This is the standard equation. Now f is function of y and y dash. Therefore, if we differentiate the f with respect to x, then df dx equal to what we get? We get del f del y into y dash plus del f del y dash into y double dash. That means del y del 2y del x2 we get, right? Now if we multiply the Euler-Lagrange equation, this equation, by y dash, this is the standard process. Okay, so we get y dash ddx of del f del y dash minus y dash del f del y, this is equal to 0. Now we put this y dash to inside this bracket, then we write d dx of y dash del f del y dash. Now if we write this inside the bracket, then this creates actually two terms, this total differentiation, which we included in this term. Therefore we have to exclude that term. And what is that term? That term is del f del y dash into y double dash minus y dash del f del y is equal to 0. Fine. See, if we break this term, actually we get y dash del f del y double dash plus y double dash del f del y dash. Okay, and we write this term, but this term is not present. This term is not present in this line, so we have excluded this term. Fine. So now what is the value of this? This value is from this line. From this line, the value is del f del x. So this means d dx of y dash del f del y dash minus df dx is equal to 0. That means we can write d dx of f minus y dash del f del y dash, this is equal to 0. That means f minus y dash del f del y dash equal to constant. So option D comes in case of calculation. So this is today's last questions of today's lecture. So how was the lecture? If the lecture is helpful, then please give a like to this video, share with your friends, and subscribe the channel. Like, share, and subscribe. Okay. So in the next video, we will one by one upload the solutions of West Bengal SET exam first, then another we jump to another topic or another series. Okay. Thank you. Let's meet in another video.